Hey guys, let's start a new problem in system design, which is called Design API Gateway. So here we will be designing API Gateway using AI. Okay, so using AI means we will be using some AI feature in our API Gateway. So let's see the normal API Gateway design, and then we will add uh, adaptive AI feature in that. Okay, so what is API Gateway? API Gateway is a single entry point for all clients request. Okay, so means let's say this is the user and he has requested and this is your server, so he sent the request, okay, to get the data, and the server will send him the response. Okay, but here you will have one more layer which is called API gateway. Okay, API gateway means you can have load balancer and then API gateway as well. You can have multiple load balancer layers wherever you want. So API gateway, what it does actually, see, it will route the request. Okay, it will route the request means, let's say if he has sent /login. Okay, so we know that this microservice will handle that. Slash images, this microservice will handle that. Okay, so he will route that request to particular server. Next is authentication. So he will check authentication, whether the user is authenticated or not here itself. So you don't need to go and check in each services separately. Then rate limiting, so he will check the rate limiting things also, like this particular user can send 60 requests per minute. So whether the request count, what is the request count, and if it is greater than the assigned request count, then it will block that request. Okay, or will send the message that try again after 30 seconds. Next is login. So he will log in, he will do all the login things here. Okay, will log in the request related information and everything. Monitoring, he will monitor, you can use some tools or something also. So you can use API gateway as a monitoring tool as well. Okay, so some example of the API gateways will be Kong, Nginx, and Amazon API gateway. Okay, so now what will be the functional requirement here? So let's see the part one without AI. Okay, so traditional design functional requirement would be, see, first request routing, we saw that. Okay, authentication, authorization, rate limiting, logging, and SSL termination. What is SSL termination? When you send request in a network, okay, and you want the secured one, right? So you encrypt that request. Okay, so at the API gateway level you decrypt it, right? So SSL termination means decrypt incoming HTTPS traffic and forward to HTTP to backend services. Now again, one more thing, he will do that request transformation. If you wanted to change your request, modify your request, okay, you can do that work here before hitting it these services. Okay, and then caching also at one place, and load balancing. So API gateway works as a load balancer also. Now high level architecture, if you see, so this is your client, this is your CDN. Okay, so CDN will store the static information, and also it will load your application faster. Then you will have a load balancer. I said that you can have anywhere the load balancer. Okay, load balancing layer. And then here you have a API gateway cluster. So means not only one API gateway, otherwise it will be a single point failure thing, right? Will become a bottleneck. So we will have a multiple copy of a API gateway. If one goes down, then we can use second one, and your application will not be down or crash. Then here you will have a service discovery. So why we use service discovery? See, we saw that let's say your service is running on one particular server. Okay, but if that server goes down, okay, that will be a single point of failure. Your application will shut down, right? So we create the multiple copy of servers. Now all this server will run on some particular port number, right? And whenever this server goes down, then new server will get created automatically using the auto scaling, right? It will have its own port number, sorry, IP address, right? So now how can you manage this different IP addresses, this dynamic IP addresses? So for that you will just assign service name, okay, service name to a service, and using that service name you call the URL. Okay, so you don't need to change the URL, and this service discovery will take care this copy of the server and then their IP addresses. Okay, it will map that service, so it will discover service for you. Now the next is then after that the request will go to microservices. Now what will be the core components here? See, the first one is routing. Okay, so let's see, you have slash user slash order slash payment, different kinds of APIs. Okay, so it will route it to particular servers. Let's say your user profile, user services on server 1, your order services on server 2, payment services on server 3, so he knows that where to route this request. Authentication, so using JWT validation or Auth API key validation, multiple algorithms. Okay, he will do authentication for you. Now the next is rate limiting. So you can make a rule there that per user this is the limit, per IP this is the limit, per API this is the request limit. Okay, the user can send. Then after that load balancing. So we have seen there are different types of load balancing, right? Round robin, least connection, weighted. So all these things you can implement in API gateway. Then caching. So cache frequent request like get slash product. So this one user is requesting multiple times, right? So cache is stored, Redis and memcached you can use. Logging and monitoring also, that is also comes into the functional requirement. Okay, so request log, latency metrics, error rates. So latency metrics means you will store the information for the latency. Okay, and it's a multiple metrics. So using that you can see what is happening in the system, error rates also. So for that what you can use Prometheus and Grafana monitoring tool. Okay, now production architecture. So here you will have a CDN, here you have web application firewall, and then you have a API cluster. So this is the actually order, and then load balancer, and then microservice. So you can have load balancing layer anywhere in the system. What would be the non-functional requirement? So it should have a low latency, like less than 10 millisecond. Okay, if user is sending request, then the response time he's getting, like in how many time the response is coming back, that should be lower. Then high availability. Okay, horizontal scaling, fault tolerance, security and observability. So normal non-functional requirements, which pretty much same for all the system design questions. Now next is API gateway with AI. So now with AI, this is the modern design and what all feature you can introduce there. Okay, using the ML pipeline, so machine learning pipeline, and I have explained machine learning pipeline in my earlier video, design questions only, so please go and watch that. So traditional gateway is rule based, while AI gateway is adaptive and intelligent. Okay, so in traditional gateway we have just set one rule and the system was following that rule, but now here this is adaptive and intelligent. Okay, dynamically it will take decision. So what is adaptive? Adaptive means the gateway automatically changes its behavior based on traffic pattern, user behavior and system conditions. One line if you say. So adaptive means dynamically adjust routing, throttling and security instead of fixed rule. Now what is throttling here? So throttling means limiting how many requests a client can send in a given time to prevent overload. Okay, so now AI use case if you see. So let's say smart routing. Okay, instead of routing it should be smart, it should use smart routing. What is a smart routing? So let's say you have slash payment. Okay, so it was sending request to payment service in traditional way. Now in AI routing, route based on latency. Okay, which server you have a multiple server, where this slash payment service is running. Okay, so it will route based on the which will take lower latency, lower time to execute. Then route based on load. Okay, which server has less load, it will route request to that load so that you will get a faster response. Then route based on user region. So for example, if the user is staying in Mumbai cluster, then if he is an Indian user, then Mumbai cluster data center will get that request. Otherwise if he is a US user, then Virginia cluster, something like that. Now intelligent rate limiting. So what is intelligent rate limiting? So for normal user, he will adjust the dynamically the limiting rule. Okay, so 100 requests per minute. For suspicious user it will be 20 requests. Okay, for premium user it will be 500 requests, something like that. Anomaly detection. So AI detect DDoS, traffic spike and unusual pattern. Gateway automatically throttle. Okay, will fix the number, means will change the number of rate limiting. Okay, then he will block the request, and then he will handle those challenges, okay, or he will challenge that request. What is the smart caching? So smart caching is AI learn frequent accessed endpoints, okay, and then cache TTL optimization. For example, this trending product cached automatically, because he knows that for that the lots of users are requesting the that API, so it will automatically cache that API. Now dynamic request prioritization, so he knows that payment API priority is greater than search API priority, right? So during load, when load increased at that time, critical request processed first, okay. Now board detection. So what is board detection? So AI detects a scrapping board and credential stuffing. So scrapping board means the program which will automatically call your APIs, okay, and it will get your application data. And what is credential stuffing? So credential stuffing is cyber attack where attackers use stolen username, password, okay, pairs from one site to log in many other site automatically. One line credential stuffing is reuse leaked credential to break into accounts. So automation, gateway block automatically. At API gateway block, so the attackers will not send the request. Now AI based architecture, so everything is same like client, load balancer, API gateway, but here one more layer you will have, which is API AI decision engine, okay. So routing, smart routing, rate limiting, dynamic rate limiting, and then security. It will check and then route your request to microservices. Now if you see more detailed, then request, you will log the request, okay. So you will have a raw data. From that raw data it will extract the feature for the ML model, okay, and then it will send that feature, it will store that feature somewhere and then send it to ML model. Then ML model will do the training, okay, ML training offline, online. Then that data will go to decision engine, that okay, the risk score for this user is this, so block this user or send decrease the number of rate limiting there, okay. And then routing, rate limiting, all this thing will decide by ML, and then your request will route to microservices. Now this is the simple example flow. So users send traffic, AI detect usual spike, okay, and then it will calculate the risk score, and he found that risk score is high. So in that case what it will do, rate limit reduced and suspicious traffic throttled and system stable, okay. Using this your system will be stable. Now the comparison, so if you see the comparison without AI and with AI, so you can see routing in without AI it was static, but now here it is dynamic. Rate limiting, it was fixed there, but now it is adaptive, okay. So caching, it was manual and now it is intelligent caching here. Security, rule based, and this one is behavior based. Then traffic handling, this is reactive and this is predictive, okay. It will predict traffic in advance and then do auto scaling automatically or cache that particular endpoint. Complexity, this is low, and of course it is high because you are introducing one more layer, which is machine learning thing, right? So now trade-off, if you see, so without AI your system was predictable, low latency, simple and easy debugging. But after AI it became adaptive, better security, predictive, and then higher complexity. So I can say, if someone will ask me in the interview, I would start, I can say that when I need to design API gateway, I would start with a stateless, horizontal, scalable API gateway handling routing, authentication and rate limiting at scale, okay. So means this is the basic functionality, it should work, and if it is working fine, then at scale I would augment it with AI based decisioning for adaptive routing, okay, anomaly detection and intelligent throttling while keeping deterministic fallback for reliability. So that's it. Thank you.